We're now ready to turn our attention to yet another discussion about concurrency and scheduler operators in the Flux class, or used in conjunction with the Flux class. And as before in our previous discussions, these operators arrange to run the other operators in designated threads or in thread pools. And right now we're going to take a look at the scheduler's parallel operator. So the scheduler's parallel operator is used to host a fixed pool of single-threaded executor service-based workers. It's kind of a mouthful, but that's the features that parallel provides. And it returns a new scheduler that's designed for use with parallel computations. And the size of the pool is dictated by a system property called Reactor Schedulers default pool size. So you could actually override that if you need to, but that's what it sets up with by default. And if you don't do anything to the contrary, then it will fall back to the number of processors that the underlying Java execution environment knows about. So if you're using a Java virtual machine, for example, then that knows internally how many cores are available on that platform. And so that's what would be used by default. You can also provide a value here if you want to. Now, the parallel factor method is optimized for computation-intensive, or so-called CPU-bound, non-blocking tasks. And the reason for that is it's got a fixed size. Defaults to the number of processor cores. You could make it bigger, you could make it smaller, but it defaults to that fixed size. And the number of threads that are in this pool don't change as it runs. So as it runs, it'll stay the same all the time. And that makes it not very useful for IO-bound operations, because for IO-bound operations, you want to be able to grow or shrink the number of threads that are in the pool as operations block. And there's actually a whole nother mechanism that's available in Project Reactor called a bounded elastic thread pool. And so that's another scheduler factor method that you can use if you have IO-bound jobs. We typically use this to leverage the default parallel scheduler in the context of the flat map concurrency idiom. We took a look at that in the previous slide set. And you can see here that we're going to pass in a parallel scheduler here that will multiply all these big integer objects in the background using the parallel thread pool. Internally, the parallel operator is implemented using so-called daemon threads, and that means the app won't be prevented from exiting even if its work isn't done when the main thread of control goes away. So remember, when there's no more so-called user threads, then all the daemon threads will automatically be shut down. RxJava has a method on its schedulers class called computation that behaves in a very similar way. It's also fixed size. It's intended for these compute-intensive or CPU-bound non-blocking tasks. And so if you try to mix and match things and do blocking operations in the wrong pool, you'll typically get an exception. So that's the end of the discussion of the parallel operator. And I probably could have done this lesson before the concurrency idiom, where we talked about flat map, but because they kind of have recursive dependencies on each other. But hopefully you can follow along by going back and rewatching that video, and now you'll understand what the parallel factor method's doing on the schedulers class.